Hi, I'm Krista Williams,
And I'm Katie Scavarna.
and we decided to do our presentation on the chemical properties and the everyday uses and application of Teflon.
It's also known as poly 1122 tetrafluoroethylene, or also known as PTFE. A picture of the structure is shown on the screen. It is only composed of carbon and fluorine atoms, and it's just a very, very long chain of them. The black dots are the carbon, and the green dots are the fluorine.
PTFE was actually accidentally discovered in 1938 by this man on the left, Roy Plunkett. He was attempting to make a chlorofluorocarbon refrigerant. So he was quite surprised when he found this substance which polymerized spontaneously to form PTFE. PTFE was trademarked in 1945 by DuPont into what we now know as Teflon.
So the chemical properties of Teflon, it is basically a long chain of the image on the right. It is formed, there's different kinds of polymerization that could take place depending on what the outcome the person wants. So it's a thermoplastic polymer. Has a high melting point, but also is very stable at low temperatures as well. It's colorless and odorless. It is solid at room temperature and often forms a waxy substance. And this waxy substance is very slippery, and that is because this molecule is very non-reactive. And it's non-reactive because the highly electronegative fluorine atoms completely cover and shield the carbon chain, so nothing can really get in to react with the carbon molecules, or the carbon atoms, excuse me. And so that's what makes it so unreactive and for a very wide use. It's insoluble in hot and cold water, acetone, petroleum, concentrated sulfuric acid, and other similar solvents which could usually react with, or that are usually highly reactive.
Some uses that we see Teflon in every day is it's mostly seen in our non-sticking cookware. Because of its high melting point, it allows for cooking and for food not to stick to it. Because of its slippery properties. It's seen as a lubricant in machinery, once again because of its high melting point. It doesn't get destroyed in those hot temperatures. And also because of its excellent, because of PTFE's good dielectric properties, it makes it a good insulator in cables. It's also used as a repellent in clothing, so it waterproofs our clothes. So like for the snow jacket, for example, when it gets wet, the water will just roll off of it rather than soaking in like our normal cotton clothing. It's also used in hair and nail products. It's used in nail polish to form a soft, slippery, smooth, uncrackable surface, as well as curling iron and straighteners. So when you're straightening your hair, the slickness of the plates doesn't pull your hair out. Another use is windshield wipers, so when it's wiping the water off the windshield, it doesn't scratch your windshield, and it makes a nice, smooth, clear view out your windshield.
So there has been questions of this compound safety in the past, and those have been brought to the manufacturers. And that's because usually the fluorine carbon interactions can be toxic, but it's been found that it is more on the manufacturing side than on the consumer side, so it is safe to use in everyday uses, but it can, if it does get too hot, so it says it starts to break down at 260 degrees Celsius, which really isn't what anyone would use in their everyday. So
Alrighty. Thank you for a great semester.